Welcome to video 5 of the FP3 chapter, Hyperbolic Functions. As usual, I'm going to start with a question on the screen for you. Pause the video, have a think about this. What is Osborne's rule? Can you write it down, all the three different parts? Osborne's rule, if you've given that a go, you should have remembered, hopefully, the first part, that all the sine x terms in a trigonometric identity change into sinh x terms. Let me get rid of that, it looks like a minus. All of the cos x terms change into cosh x terms. And the third part, very important, any sine squared or implied sine squared x turns into a minus sinh squared x. So an implied sine squared would also be something like a tan squared. Okay, hopefully you have remembered that. This final video then is looking at solving hyperbolic equations. There's not very much to the notes in this video. We've done most of the work. This is just applying what we've learned to solve hyperbolic equations. So I'll go through a few examples in depth and then you can practice for yourself. So you might not be surprised by this, but hyperbolic equations can be solved in all the usual equation solving ways. What I mean by that is if you've got a quadratic in there, you solve it in the usual quadratic way. You might have to use some hyperbolic identities like I've written here. That's not unexpected. If you were solving a trig equation, you would expect to use a trigonometric identity perhaps. You might also be required to start from the exponential definitions of the hyperbolic functions. This is perhaps a little bit different to things that we've done before. So I'll just go through a few examples to give you an idea of what sort of thing you might have to do in the exam. This first question, solve 6 sinh x minus 2 cosh x equals 7 for real values of x. Now this is a little bit interesting because if you were to do a similar sort of question, let's say 5 sine x minus 3 cos x is equal to 2, just as a quick example, that is not a particularly easy question to do. Converting the sine into a cos or a cos into a sine is not as easy as, say, a sine squared or a cos squared. And because of this 2 over here, it's not going to easily convert into tan x either. So although you probably have enough knowledge from your other work to be able to solve this by combining those in a slightly different way, it's not a straightforward equation as compared to the hyperbolic equation we've got here, which is a lot easier because we don't have to combine them into one hyperbolic function. We can just use the definitions of sinh and cosh in the exponential forms, which is what I would suggest doing to solve a question like this. So here we go. Let's go sinh x is e to the x minus e to the minus x over 2, so we'll do 6 times that. Cosh x e to the x plus e to the minus x over 2, so minus 2 times that, and all of that has to equal 7. So our exponential equation here is much easier. We're just going to expand it all out and see what we can do. So of course we've got the 2's cancelling that. 6 becomes a 3. So we've got 3 e to the x minus e to the x is 2 e to the x. And minus 3 to e to the minus x minus another e to the minus x is minus 4e to the minus x, and all of that has to equal 7. Now we've seen something like this before in some of the other videos. We've got an e to the x and an e to the minus x. So what I'm going to do is convert that by multiplying by e to the x into something that is more obviously a quadratic in e to the x. So I'll have a minus 7 e to the x from that term on the right, and a minus 4 because e to the x and e to the minus x will cancel out. And then you can apply your formula, or if it looks like it will factorize, it looks like this one will, then we can try and factorize it. We'll have a 2e to the x and an e to the x, and looks like a 4 and a 1. I have a minus 4 here, that gives us minus 8, and a plus 1 here. Yes, that will work. So we've got our two parts to this. E to the x from the first bracket equals minus 1 over 2, or from the second bracket, e to the x equals 4. And perhaps at this point you can see why they've put in this little real values of x, because this one here won't give us any real values of x, because e to the x cannot produce a negative answer. So let's just take the logs of this, and our final solution is the natural log of 4. Okay, that's the first one done. Let's have a look at the second one. Solve 2 cosh squared x minus 5 sinh x equals 5, giving your answers as natural logarithms. Okay, we'll come back to that little bit, natural logarithms, at the very end to make sure that we've done that. But to solve this, probably you can see the similarities with a trigonometric equation. If you can change a cosh squared into a sinh squared, it becomes a quadratic in sinh. So let's use the identity that we know from our previous video to help us change this. So cosh squared will be 1 plus sinh squared. Remember, that's different to the trigonometric version of this hyperbolic identity. So we've got 2 times 1 plus sinh squared x minus 5 sinh x. Let's bring that 5 on the other side, and that has to equal 0. So when we expand this out, we get 2 sinh squared x minus 5 sinh x minus 5 plus 2 is minus 3. Now at this point, we can probably check, see if it factorizes. Let's give it a go. We're going to have a minus 3 and a plus 1. So if we put 2 sinh x here, that will give us minus 6, and a sinh x here gives us minus 5 in the middle. Yes, that will work. So we've got sinh x must equal minus a half, or sinh x must equal 3. Okay, now we've got sinh x, not x. So this is where our natural logarithms come in, because if you remember, to get x out of this, we're going to be doing the inverse, or r sinh. Oh no. R sinh of minus a half, and x equals r sinh of 3. And to get that r sinh, you could just stick it in your calculator, but if the question wants you to write it as a natural logarithm, your calculator probably won't give you that form, and it's more likely to give you a decimal. If that's the case, if it does give you a decimal but you need a natural logarithm, go back to the definition given in the formula booklet for r sinh x in terms of the natural log. And then we can just put minus a half in here, see what we get, and put 3 in here and see what we get. So that x is equal to natural logarithm of minus a half plus the square root of minus a half squared is a quarter plus 1. Or x is equal to the natural logarithm of 3 plus 3 squared is 9 plus 1 is 10, square root of 10. Now the one on the right is just about as tidy as I can make it, but I can make the one on the left a little tidier. Minus a half plus the square root of, now the 1 will be 4 out of 4, so that's 5 out of 4, so that's the square root of 5 over 2. Or if you wanted to combine that, the log of the square root of 5 minus 1 over 2. And there are our two answers, given as natural logarithms. Okay, that's the second one. The third and final example. Solve cosh 2x minus 5 cosh x plus 4 equals 0, giving your answers as natural logarithms where appropriate. So we'll check that at the end, see which one can be natural logarithms, and the question is kind of implying that maybe one can and one can't. So we'll have a look at that at the end. But to start us off, similar again to a trigonometric equation, we don't really want this 2x here and an x here. If we can, we want to make those two arguments, if you will, of the hyperbolic function the same. So we can use a cosh 2x identity. Now, a quick note on this, because in the previous video we tried cosh squared x plus sinh squared x, and I said that gives us something not very useful, not realizing that if you were to cancel the 2's and the 4's in the fraction, that it did actually give you cosh 2x. So it is quite a useful identity, but it wasn't the one that we looked at in that previous video. So apologies for the not quite accurate information in that video. It does have its use, and we're going to use it right now. So cosh 2x, we're going to change that into cosh squared plus sinh squared minus 5 cosh x plus 4 equals 0. And you can probably see what we're going to do now. We've got a sinh squared there that we can change into a cosh squared minus 1. So that's going to give us 2 cosh squareds. We're going to have a minus 1 with the plus 4, but we're still going to have the minus 5 cosh x. Minus 1 plus 4 is a plus 3. Let's see if we can factorize this. Quadratic in cosh, we're going to have a minus 3, a minus 1, and that will have to be 2 cosh x here, and cosh x here. So cosh x must equal 1, or cosh x must equal 3 over 2. And again, to get x out of this, we're going to need r cosh. So back to the formula, r cosh x is equal to the natural logarithm of x plus the square root of x squared minus 1. And perhaps now you can see why they've written this where appropriate here, because if we put that first one, a 1 in here, we're going to have 1 squared minus 1, which is, of course is 0, and then a 1 plus 0 is 1, and the natural logarithm of that 1 will give us x is equal to 0 over here. So the r cosh of 1 is 0. So we don't need a natural logarithm there. But this other one, we will. So x is equal to natural logarithm of 3 over 2 plus the square root of 9 over 4 minus 1. And then again, you should tidy that up like we did in the previous example. The 1 there gives us a 5 over 4 again. So you end up with 3 plus the square root of 5. 4, when you square root that, you can combine that into a half. And here are our two answers. So I hope that shows on the second and third example the similarities between trigonometric equation solving and hyperbolic equation solving, but on the first example a slight difference where sometimes the definitions will make it much easier to solve. Or you might be required in a question to use the definitions if that's what they want to test. So you've got all of the content now. You can give the exercise 1D a go from question 5 onwards, and also the chapter 1 review exercise, because this is the final video in chapter 1. I'll maybe see you next time for chapter 2.